Hi everyone. So in my previous video, we were able to send data from an Arduino to Python using the Pyserial library. In this video, we are going to build on that and send the data we collected to the cloud. Now if you haven't seen my previous video, do check it out by clicking the link up here. Now there are multiple cloud platforms out there, but in my opinion, the simplest and probably the easiest to use is Google Sheets API if you just want to log data and maybe use a few basic visualizations. So without waiting any longer, let's get right into it. Now if you guys like this video, don't forget to give me a thumbs up by clicking the like button below. And if you haven't done so already, please subscribe. I'm Chums and welcome to ThatsEngineering. So this kind of approach would be useful if you are using an edge computing approach to our IoT or cyber physical system development. So if you have a certain amount of computations or processing to perform, and if it has to be done in real time with low lag times, low latency, then pushing the data to the cloud and performing the computations there might not be the most suitable. You're better off processing the data locally and pushing the results of that data into the cloud. So this sort of approach is applicable using Python because we can perform our machine learning and our algorithms locally and push the results of that into the cloud rather than just the raw sensor data. You would have to take into account the extent to which you will be processing the raw data and maybe some of the specs on your computer, such as processing power or speed. So I made a quick flowchart to show what we will be covering in this video. We will first configure Google Sheets API, install the required Python libraries, and collect sensor data from an Arduino. Now I went through that in my previous video, so I won't dwell on it too long in this video. I don't have a real-time clock on my Arduino, so I will append a timestamp using Python itself, perform whatever algorithms or computations we're performing, and then push that data to the cloud. And once we're in the cloud, we can create a few basic visualizations to display the data that we've collected in a dashboard format. Alright guys, so to configure Google Sheets API, you will first need a Google account. After you've set that up, go to your browser and go to console.developers.google.com. Right, so your front page might look a little different if you're setting it up for the very first time, but I have a few previous accounts, so that's why it has these options given here. So you'll go on top over here and click New Project. Right, so you can give a name for your project. I'm just going to call mine test video, for example, and click Create over here. Right. So just wait until it's created, and once it's created, go ahead and select that particular project, test video. Right, so we will need two APIs, the first being the Google Drive API and the Google Sheets API. So go to Library and search for Google Drive. Okay, Google Drive. And once that loads, click Enable. So give it a few minutes for it to enable itself, and after that you will have to set up a few credentials. So go to your top right hand corner over here and press Create Credentials. Right, so here you will choose Google Drive API, and where will you be calling the API from? Choose Web Server. Select Application Data and then select No and click What credentials do I need. Right, so you'll need a name for your service account. I'm just going to put my own name, Shams123 for example, and I'm going to select a role and I'm going to go to Project Editor. Right, then I'm going to make sure this is selected, JSON, and press Continue. Right, so it will actually give you a JSON file that will download, and keep the JSON file because you will need it a little later. Right, we're now going to go back to our library and get the next API, which is the Google Sheets API. Click on that and then click Enable. Alright, so that's about it for configuring your Google APIs. Alright, so now that Google Sheets API has been configured, let's go and look for that JSON file that we downloaded. So I'm going to go to Downloads, and this is the file over here. I'm going to cut it and go to my project location, and I'm going to paste the file over here. I'm going to rename this file to creds.json just so that it's easier to refer to it when I'm writing the code and in the program. Now I'm going to open this file using PyCharm. So this is my project and this is the file creds.json, and the field that we need from this file is this field over here, client email. Right, so you're going to copy this client email over here. Right, copy that and then go to your Google Drive and create a spreadsheet. So I've already done that and I've named mine test video. Go to share and paste that client email. Click enter and send. Right, and you can confirm that the client email is over here. Done. Right, after that I'm just going to label my fields. I'm going to have a date, I'm going to have a time field, and since I'm using a DHT11 temperature and humidity sensor, I'm going to have a temperature field followed by a humidity field. Alright, now let's go back to Python and have a look at the Python code. Right, so I will first go through the libraries that I used. The serial library over here is the Pyserial library, which allows communication between the Arduino and Python. The time library is used to get the date and time, and the schedule library is used to schedule the data collection so that it will run periodically, for example every 1 minute, 2 minutes, so on and so forth. So the most important library here to allow communication to the cloud is this particular library, gspread. So you can get it by going to your terminal and typing in pip space install space gspread space auth to client and click enter. Right, so I already have this library, hence it's telling me the requirement has already been satisfied. But if you don't have this library, the installation will start. You can find the documentation for this library by going and looking for it, searching for it online on pypy.org. Right, so let me start with the code all the way at the bottom over here. So I initialized a few values and I started with the schedule command, which runs every 10 seconds, and every 10 seconds it will run this particular function, main function, which performs the data collection and pushing the data to the cloud. I've used a while loop to run the pending schedule command, and I've used a counter set at 60. So it will collect 60 data values and then it will break out of this while loop and finish the data collection. So you don't necessarily need to have this if you just want to keep collecting data, but I just set that in here just to collect 60 data points. Right. Then we will have a look at this function, main function over here. So this bit of code I've actually covered in my previous video, and that is practically establishing a connection between the Arduino and Python. Over here I'm obtaining the data, decoding it, converting it into a string format. I'm splitting the data based on a delimiter, and I'm changing it into a float, a floating point number, and just appending it into this variable list in floats. So the circuit diagram for the Arduino, the code running on the Arduino, and this block of code over here, I have explained it in detail in my previous video, and I will leave a link to that video in the description down below So if you're not quite familiar or not quite sure how we got up to this point, do check that video out. Right, so what's new is this point over here. So I've used this function, get the date and time, to get the date as it is to get the date and time. Self-explanatory. So that function is right over here. I'm getting an array. The array has two elements. The first element, which is the 0th index, gives the date, month, and the year. The second element, which is the first index, gives the hour, minutes, and the seconds. And that's appended to this array and returned back over here where it's stored in this particular array, the date time array. I then call this function push data to the cloud, which has two arguments. It has listing floats, which is the data coming in from my sensor. So right now it has just two values, a temperature value and a humidity value, and the date time array containing the date and time. Then I have established or initialized the counter here as a global variable, and I increment the counter each time. So every time I collect a new set of data, the counter is incremented. I'm just clearing some variables here and closing the connection to the Arduino after each data collection is successful and finished. Right, so the main function over here is this particular one, which allows communication to the cloud, and I've named it push data to the cloud. It has two arguments, the data to be pushed to the cloud and the date and time. Right, so one thing you will need is this particular variable here, scope, which has to be used as it is. You need these exact 4 URLs. So I will leave a link to this code in the description down below. So you can just copy this scope, this variable here, without having to type each URL out by hand. So you need these exact 4 URLs. I'm then using the credentials file that we downloaded, the credentials.json file, and I'm using that to establish the client. And based on this client, I'm opening this particular spreadsheet, and from this spreadsheet I'm opening the first sheet, sheet 1. Right, I then prepare the data to be pushed to the cloud, an array containing all the data values. So the 0th element of my date time, the first index, the 0th index of my push data, which is my temperature reading, and the first index, which is my humidity reading. I'm then using this attribute sheet.appendRow to append the data and send it to the cloud. So it will actually append the data on my Google spreadsheet to the row that is available, so the next available row. Right, so now let's go ahead and run this code. Before that, let me first connect my Arduino. Right, and then I am going to run the code. So the program started. It will now try to establish a connection, a serial connection between the Arduino and Python. Right, connection established. Then it will collect the temperature, humidity readings, get the current date and time, and push it to the cloud. And this process will repeat every 10 seconds using this, because of this schedule function that we have used over here. So you can actually change this depending on whatever period you want. It can be minutes, hours, days, so on and so forth. So it's just going to keep logging data every 10 seconds. So I'm just going to let it run, and we're going to go back to our Google Sheet, and you can actually see the data being logged real time. So if you wait for another 10 seconds, you'll probably see another data point. It just came on. So now let me show you a few basic visualizations. Alright guys, so now I'll show you a few basic visualizations. I've actually let the code run for about 5 minutes, so it's collected quite a few data points. Right, so one thing you can do is go to Insert, Chart, and you can add a particular chart to show the trend or the variation in the data. So this has already been added to temperature and humidity, but I'm going to remove this, 2 labels, and add the series again. So you can go to Add Series and select the data range, temperature, and you can add another series for humidity. Right, and it would actually plot out here, and this chart would update dynamically as the values in the spreadsheet were updated. You can reference these charts in another sheet and have the values collected in a separate sheet so that you can present these as a dashboard in a nice way. You can also change the type of charts. You have column charts, you can have shading under your charts, and there are so many things that you can do. So one thing that you can do to get more visualizations than just using charts is go to add-ons, get add-ons, and you can download and install any one of these add-ons for your Google Sheets. For example, Google Analytics, which would help you to analyze the data you collected and find trends and variations in the data, so on and so forth. So I've downloaded one, and I think I can just show it to you here. Go edit chart, and you can actually implement things like pie charts. You can have geographical maps to show the variation in data based on a particular geographical location. You can have a gauge, so on and so forth. So that's how you would actually be creating the dashboards, and these dashboards, these charts that you create, would update dynamically based on the data that is coming into your spreadsheet. So one thing I forgot to mention was where you can run your algorithms or your machine learning to implement your edge computing approach. So I'm going to go back to PyCharm, and at the top here in main function, before you push the data to the cloud, you can actually run your computations. So call whatever functions you need. So you can call whatever functions, do your processing, your algorithms, whatever, get the results, push the result to the cloud, and you should be good to go. Alright guys, so that's all for this video. If you guys liked it, don't forget to give me a thumbs up by clicking the like button below. Now if you guys have any questions or clarifications on the work we just did, please leave a comment and I will do my best to get back to you. So just a heads up to everyone, to my subscribers out there, I am a bit busy. I've been working on a project involving biomechanical engineering, gait analysis, muscles, surface electromyography. So hopefully in the next few videos, if I can complete that project, I should be able to show you guys what I did and the results of the study that I conducted. So stay tuned for that. I'll see you all in the next video. Cheers and stay safe everyone.